Hey everyone, and welcome back. Today we are exploring a truly groundbreaking frontier together. We're diving right into the intersection of generative AI and professional game engines. Specifically, throughout this explainer, we're going to unpack exactly how the Model Context Protocol, or MCP, is automating Unreal Engine.
Okay, let's dive right into this, because it's literally the ultimate fantasy, right? You open up a chat window, type a quick prompt, and just sit back as this massive, complex video game builds itself right before your eyes. But to understand how close we actually are to that reality, we have to look under the hood at how these systems actually communicate with each other. Section 1. The binary bottleneck. So before we can even talk about AI taking over game development, we have to zoom out and look at this massive wall we hit almost immediately. You see, our generative AI models, things like Claude, Gemini, or coding tools like Cursor, they thrive on readable text. They are fundamentally text-based systems. But Unreal Engine, well, it relies heavily on unreadable proprietary binary data files saved on your disk, primarily those .uasset files. What this means in practice is that, natively, the AI literally cannot read or write the core content files of your game on your hard drive. It's kind of like having a brilliant architect who speaks a completely different language than your construction tools.
Section 2. Enter Model Context Protocol. Now, Epic Games obviously realized this massive gap, and that led to an incredibly clever, albeit temporary, workaround in Unreal Engine 5.8. Let's define exactly what this is. The Model Context Protocol, or MCP plugin, is an experimental feature that runs a local server directly inside the live Unreal editor. It essentially turns standard developer tools into APIs that an AI agent can call. Think of it like a remote control. The AI isn't building the game from scratch on your hard drive, rather it's acting more like a puppeteer, actively pushing buttons on the editor's remote control while the whole thing is up and running.
And this brilliantly illustrates the elegance of the solution. First, the AI generates a creative intent based on your prompt. Second, it fires off a simple JSON RPC message to your local host. And finally, the MCP plugin catches that message and executes the command directly inside the live editor. The AI completely bypasses those impenetrable binary files on disk by sending HTTP commands over a local 127.0.0.1 connection right to a running instance of Unreal Engine. There's this great quote from Adam Hafez that perfectly summarizes the architecture here. He says, Claude Code is talking to Unreal through the MCP server, reading the scene and taking actions directly inside the engine. The AI never touches a file on disk. And Epic's own flagship AI demo showcased an agent doing precisely this, driving blueprint logic, spawning Niagara visual effects, and updating HUDs entirely through this live proxy model. No saving files, just direct live manipulation. Section 3. The Flux Point Implementation. So let's shift our focus to what this technology actually looks like in the wild. We're going to use the open-source Flux Point Studios repository as our primary case study here. Now, what's really interesting about this is the sheer, comprehensive scale of control. This isn't just some basic weekend demo. FluxPoint has built a native C++ automation bridge that exposes 36 distinct MCP tools and well over 200 action handlers directly to the AI. We're talking asset management, actor and physics control, editing blueprint and material graphs, and even digging into system-level functions like console variables. And listen, this isn't just a hacky script either. The backend features dynamic type discovery, which means it has runtime inspection for complex things like lights and sequencer tracks. But more importantly, it enforces command safety using pattern-based validation. Basically, it actively blocks dangerous console commands to stop an overly eager AI from just completely breaking your system. Section 4. Hype versus reality. All right, while this technology is incredibly exciting, we definitely need to slow the hype train down for just a second. This is an early-stage pipeline tool, not a fully autonomous technical director. There are very real limitations you have to understand. First off, the system is highly experimental. Crucially, tool calls execute serially on the game thread. That means there are rigid limits to how much an agent can actually run in parallel without choking the engine entirely. There's also no authentication layer, and it binds strictly to local connections by default for security. Any studio looking at this absolutely needs to test it thoroughly in a sandbox environment before even thinking about throwing it in the live production. Section 5. AI Philosophies. Epic's protocol level versus other community approaches. So Epic's protocol level approach is a massive leap forward for sure, but it's sparked this really active philosophical debate within the developer community. Let's move to and see how this builds into competing ideas. Competitors like Ludus AI, for instance, argue that the generic MCP approach is inherently slow and expensive because the AI model acts like a blank slate on every single request. It has to blindly rediscover your project's entire class hierarchy call by call. Instead, Ludus AI uses an index-based approach. It actually scans the entire project every 5 seconds to maintain this deep, persistent semantic awareness of your naming conventions and your existing systems. It's a fascinating look at the different ways developers are trying to bridge that gap between AI and game logic.
Section 6. The road to UE6. Let's zoom back out to the horizon for a moment, because as cool as the MCP proxy server is today, it's really just a bridge to a much, much larger shift. We're looking at a multi-year roadmap here. We've moved from storage architecture updates back in UE 5.4 to today's experimental MCP proxy in UE 5.8. But the final destination, slated for early access in late 2027, is Unreal Engine 6. And UE6 is where the engine systematically abandons those old binary files to embrace a completely unified, distributed future.
So the absolutely crucial point here is this. Epic is actually phasing out the visual, binary-heavy blueprint system in favor of their proprietary programming language, Verse. And why is that such a game changer? Because Verse is text-based. Alongside migrating to open formats like GOTF and USD, this means AI agents will finally be able to read, write, and refactor game logic directly on your disk. No running editor proxy required.
And to support this massive structural shift, Epic is also open sourcing a completely new version control system called Lore. Designed to basically replace legacy tools like Perforce, Lore is purpose-built from the ground up to handle multi-gigabyte binary 3D files without choking. This is going to allow massive, distributed networks of creators to collaborate seamlessly on the exact same project alongside their AI assistants. So I want to leave you with this final provocative thought. Right now, yes, we're using local servers to puppet a visual editor as a workaround. But what happens to game development in late 2027 when the engine is entirely text-based, natively distributed, and structurally open to any AI agent right out of the box? The fantasy of prompt to game isn't just marketing hype anymore. It's being actively embedded into the very foundation of Unreal Engine 6. Thank you so much for joining me for this explainer. Keep learning, and I'll see you in the next one.